on my first video cut off, but all I did here to finish up was take this second factor and set it equal to 0 and solve for k, and I ended up with k equaling plus or minus 3. Then we're going to jump down to problem number 3. Problem number 3 doesn't have us solve for r or k. This time it says show that y equals 2 plus e to the negative x cubed is a solution to this differential equation. So I am going to approach it the same way, but I'm just going to prove that this truly is a solution. Here's how we do it. I'm going to write my differential equation over here. Y prime plus 3x squared y is equal to 6x squared. And then I'm going to write my function over here that I'm trying to prove. Just like before, I have y in my differential equation. I'm going to replace it with this y. I also happen to have y prime over here, which means just like before, I need to solve for y prime. I need my derivative. Well, the derivative of 2 is 0, so that's gone. The derivative of e to the negative x cubed is e to the negative x cubed times, chain rule, negative 3x squared. And I'm just going to take this and substitute this value, or this entire function here, in for y prime. So let's rewrite. Y prime is going to be replaced with, I'll write the negative 3x squared in the front. E to the negative x cubed plus, I see a 3. I see an x squared. In for y, I'm going to put this value of y in. So 2 plus e to the negative x cubed. And it's supposed to be equal to 6x squared. To prove that this truly does work, I need to simplify my entire left side until I get 6x squared. So I'm just recopying this first term. Plus, I'm going to distribute this 3x squared through, giving me 6x squared, and also giving me a plus 3x squared e to the negative x cubed. Still supposed to be equal to 6x squared. One thing I notice is I have a negative 3x squared e to the negative x cubed and a positive of the exact same thing. Those are going to cancel out, leaving me with just 6x squared on the left side and 6x squared on the right side. And at this point, I have shown it, or I have proven that that is a solution. Okay, we will do more with differential equations as the packet goes on, but for right now, that's all we're doing in terms of working with a differential equation. If you flip your paper over to day 2, we are now going to be graphing differential equations, okay? And to graph a differential equation, what it graphs into is something called a slope field. And the reason that it's called a slope field is because a differential equation has a dy dx, which is just a derivative or a slope. And so if we read up top, it says, a slope field is a graphical representation of the slope of a function at various points in the plane. And we're going to be given a differential equation. Example 1, we're given dy dx is equal to x. And we're going to be asked to sketch a slope field. So we are asked to come onto this xy axis that we've got and to sketch what the slope is at every single point we see. Well, I'm going to label my x-axis just to make this a little bit easier. And whenever you're given a slope, a differential equation, always pay attention to what it's equal to. In this case, there's only x's in what it's equal to. If it is easier for you, I might suggest that you make yourself a table when you sketch these. Since there's only x in my differential equation, I'm putting x here. And then over here, instead of putting y, I'm putting dy dx, which is the slope. If I were to begin with the smallest x value that my graph is showing me, it would be negative 4. And if x is negative 4, if I go into this differential equation, the dy dx is also negative 4. So what that means for me when I sketch my slope field is over here at every single value when x is negative 4, all these dots straight up and down, I'm going to draw little tiny lines that have a slope of negative 4. And again, we're just estimating that. Negative 4 is a pretty steep slope, and so I'm doing my best to draw it pretty steep and to make all of these look like they have approximately the same slope. Let's go to -3. When x is -3, dy dx is -3. So here, I'm also going to have a negative slope. It's not going to be quite as steep as the -4, but the important thing is these should all be the same. I'm not going to fill out the whole table. I think we can get the hang of this. At -2, it's a little bit less steep. Slope of -2. At -1, it should look like about a 45-degree angle here. Slope of -1. What about at 0? At 0, dy dx is equal to 0. Well, think about what a little line with the slope of 0 looks like. Looks like a little horizontal line. And at 1, we move over to positive slopes. At 2, +2, a little bit steeper. At 3, even steeper. And at 4, a +4 slope. And that's what you can do, especially if there's only one variable. If there's only an x, the slopes are going to be the same straight up and down as we go through this. All right, let's take a look at example 2. Example 2 says dy dx is equal to y. So this time when I look at my graph, the y values are going to be important to me. So I'm going to label my y-axis. And if I used a table to help me, which I recommend at least at first, y is the only variable that needs to go here because my differential equation only has y. dy dx is going to go here. Along my y's, I'll start down at -3. When the y value is -3, the dy dx, or the slope, is also -3. So that means, think about your slope field. All of these points right here have a y value of -3. Okay? So on all those points, I'm going to draw little lines that have a slope of -3. At -2, my slope is -2. So it's still negative, just not quite as steep as the -3. Keep going. -1 still has a negative slope, not quite as steep. At 0, which when y is 0, we're talking about straight across the x-axis here. My slopes are 0. Remember, a slope of 0 is a little horizontal line. So these look like this. And then at 1, my slope is 1. So now we've got little positive slopes. And at 2, a little bit steeper. And at 3, steeper. And on your AP exam, the most that I've ever seen that they ask you to plot, they don't typically ask you to plot an entire slope field. The most I've seen, I think, is probably 9 to 12 different points along there. Okay, number 3 gets a little bit more difficult because number 3 has x's and y's in your problem. So let me set this one up. So for this one, I'm going to label my x and y axis. 1, 2, 3 is enough. 1, 2, 3. And I do recommend, if you get one of these on the AP exam, to actually take the time to plot your point and see, or to make a table with your point, because they're only going to ask you, 3 to 12 different points for you to do. Make a table. Take the time to do that. Don't rush through that portion. So this time I have x's and y's. So x and y, and I want to know what the slope is. So typically what we do is we look for patterns. We don't want to go through every single one of these points, like -3, 1, -3, 2. That would kind of be a waste of time. So instead what we do is I look at my equation here, my differential equation, and I say, is there anything that would always produce the same answer? Now this is the first thing I notice. When x is 0, I don't care what y is. Y could be anything. But when x is 0, my slope is 0. So I'm going to put all those in. When x is 0, that's straight up and down here. When x is 0, my slope is 0. Another pattern, what about when y is 0? When the y value is 0, doesn't matter what x is, my slope is going to be 0. So that's all here. Okay. Then at this point, if you don't see any other patterns, I would just go quadrant by quadrant and go through. I'll start in the first quadrant. And this is, you can do this any way that you can. This is the way that I would typically do it. I would say, starting in the first quadrant, 1, 1. Well, 1 times 1 is 1. So at 1, 1, I have a slope of 1. Then I'd say 1, 2. Well, 1 times 2 is 2. So at 1, 2, I'm a little bit steeper. At 1, 3, 1 times 3 is 3, a little bit steeper. Then I'd come over here. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6, getting steeper. From here, 3 times 1 is slope of 3. 3 times 2 is a slope of 6. 3 times 3 is a slope of 9. That's pretty steep. But I can get the idea of what the shape should look like over here. We'll come over here into the second quadrant. Negative 1, 1. Well, negative 1 times 1 is negative 1. Negative 1 times 2, negative 2. Negative 3. And keep going through all these points. You'll see for this particular differential equation, they kind of get steeper as we move left and right. Down here, negative 1 times negative 1 is 1. So positive 1, positive 2, positive 3. And keep going. You'll notice they get steeper as you go. If you need to take the time to fill out the slope field, then that's fine. Or to fill out the table, then that's fine. 1 times negative 1. That's a slope of negative 1. A little bit steeper, a little bit steeper. And they don't need to be perfect. As you get better at them, you'll just fly through them pretty quickly. Okay, and problem number 4. Problem number 4 is, again, x's and y's. I'm going to look for some kind of pattern if I can on here. So I'm going to set up, or I'm going to label, I should say, my x and y axis. Set up my table. X, I need y's, I need dy dx's. Okay, this time my differential equation is y minus x. So I might say, okay, what would produce a certain pattern? And if I'm subtracting the two, one thing that I notice, what would happen if they were the same number? This was 2 and this was 2. This was 3 and this was 3. If it is the same number, I don't care what the number is, but if it's the same number, my slope is going to be 0. So I like to look for those 0 slopes first, just to kind of get them out of the way. So what I mean by the same number, like 1, 1, 2, 2, 3, 3, 0, 0, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. Kind of looks like a staircase going up there. Okay, I'm going to look for something else. If the y value is 1 more than the x value, so I'm thinking like 1 minus 0. Let's see, if x was 0 and y was 1. If the y value is 1 more, my slope is 1. So at the point 0, 1, my slope is 1. Let's do it like this. The y value is 1 more. 2 minus 1 is 1. So at my point 1, 2, slope is 1. It's going to be true straight up and down this diagonal line. Kind of looks like a slant asymptote in there a little bit. And then from this point, I would just start looking for pattern, or not, I'm done looking for patterns. I would actually just start plotting points now. So I just come each point, I'm going to go to the first quadrant here, and the point that I've left that I haven't touched in the first quadrant is 1, 3. So 1, 3. Well, 3 minus 1 is 2, so my slope here is 2. Then I'd go and make this table if you need to. Some of you are going to be able to do this quickly in your head, or quicker in your head. If you need the table, please, please, please use it. 2, 1. So according to my equation, it was y minus x. 1 minus 2 is negative 1. So right here, my slope is negative 1. At 3, 2. 2 minus 3, it's negative 1. Oh. What I'm noticing is these slopes look like they're turning into -1. Let's try this. 1, 0. Well, 0 minus 1 is -1. Do you see the pattern here? Okay. And then just keep going. You'll see that as you keep going, you'll be able to catch on to the hang of this. You could certainly make all your points. Again, don't stress about this though, because on the AP exam, the most we've ever seen is asking you to make 12. Let's see this one. This would be positive. A little bit steeper. And it's okay if it's not perfect, as long as you've got the pattern down for it. Something that you might be asked to do, and we'll try one more of these on the back page. Something you might be asked to do is draw a solution curve through one of them. So let's flip to the back page. We're not going to do all three, but on the third page, there are 3 examples, and let's try that top one. The top one says dy dx equals 2x. Okay, so for this one, I noticed that x is the only variable that is in my differential equation. So if I were to set up a table, you don't need to, but if you wanted to set up a table, I would just put x and I would put dy dx. And I would say when x is -3, well, 2 times -3 is -6. So all these straight up and down here are pretty steep with the slope of -6. Then if I go to -2, slope of -4, still pretty steep negative slope, but not quite as steep as the last one. Next one, -1. Well, 2 times -1 is -2. That is still a negative slope. 0. 0 would produce, sorry, this angle is a little weird. 0 would produce a slope of 0. 1 would produce a positive slope of 2. Notice the slopes are the same straight up and down when x is the only variable in the differential equation. Slope field should look like that. The thing that you might be asked to do after drawing a slope field is you might be asked to draw a solution curve through a certain point. So let's draw a solution curve through 0, 1. Now what you do when you have to draw a solution curve is you come onto your slope field and you go up to whatever point they're talking about. So 0, 1, it's right here. I'm going to put a dot there. And if I were to follow the pattern of all these little lines that I've drawn on my slope field, and I have to draw a function that goes through this point, I can have a pretty good idea of what it's going to look like. It's going to look like a parabola. Okay, it's going to go through that point. It's going to look like a parabola. I could ask you for a different point. So I could ask you to draw a solution curve through, let's say, 2, -2. So 2, -2 is right here. I'd come to 2, -2, and I would follow the pattern. Again, it would look like a parabola. Okay, so if you'd like, you can try example 6 and 7. I will upload my solutions to those. I worked out solution key to this up on Google Classroom. If you want, you can try some of these whitebook problems as some practice. But the homework packet will also be posted, and I would suggest going through the homework packet. So the homework that goes with this is homework number 1. And if you've been keeping up with the live stream videos from AP, from College Board, you might notice that our homework number 1 is one of the videos that they went through on one of the first 3 days that they introduced this, this topic. Okay, enjoy.